Because of the length of the video, I've decided to break this up into multiple parts. So let's begin with part 3. In part 1, we examined the unit and did some basic checks on the power supply and all the components, and found that the power switch was bad. In part 2, we examined the power supply. We removed the electrolytic can, restuffed it, and reinstalled it. Then recheck the power supply. So let's begin with part 3. Now I need to replace this old cap here. What I'm going to do is I'm going to clip out the leads so I can get in and solder it. Now while I have that cap out, that's this cap right here, I'm going to check this 470 ohm, yellow, brown, brown. That's it right there. $472. So that's good. Okay, the electrolytic is in. Let's mark this cap and this resistor. It's being checked and good. Okay, let's start taking a look at some of these paper caps here to replace them. The most really important one probably is this one right here. This cap goes from line to ground. That cap needs to be replaced with a safety cap. There are two different types of safety caps. If we can look at the values here, which I don't know if I can get, you can see that it's listed as X1, 440 volts, and Y2 at 250 volts. The X is the nomenclature for going across the AC line. The Y is from going from line to chassis ground. Now there are 3 different ratings on this. There's an X3, an X2, an X1, a Y3, a Y2, and a Y1. I believe that the 2 ratings are for residential, and the 1 ratings are for industrial. I've never seen a 3 rating. I have no idea where that's used at. If somebody knows, please leave it in the comments. But what we're going to do is we're going to replace this with this cap. This is called an XY or a safety cap. And this is going from line to chassis ground. You can see that this cap has gotten warm. A little bit cracked here. If I had a cap checker on the bench, we could check this. In one of my past videos, I redid this power supply can and restuffed it. You can do the same thing with the paper caps. I don't think that it's important enough to do that on this unit. We will replace this one with a safety cap. Okay, that cap is in. Let's go ahead and mark it off on the sheet. Okay, the next one let's tackle is this capacitor right here. The other side hooks to a resistor that is red, red, green, which is 2.2 meg. And the other side goes to a brown, black, green, which is a 1 meg. So let's go ahead and cut this out and replace that and check those 2 resistors. Now if you notice, there's a line here. That line is for indication of foil side. It says right here, outside foil. We want to make certain that that foil goes to ground when we put the new capacitor in. Okay, when I touch my finger on the probe, you can see that I'm injecting noise onto the scope. That noise is what we're looking for. So if I go across both legs of the capacitor and I put my finger on the outside of the capacitor, I'm looking for the noise level that's there. It looks like in that instance I'm only getting about 1 division. If I change the probe to the other side, it looks like I'm getting 2 divisions. So that would be the highest injection point from my fingers onto the case of the capacitor. So that would be the lead, that would be the outside shield of this capacitor. Then we would put a mark on it indicating that's the outside shield. With the new orange drop-in, you can see that I've taken the marking here, which is the outside shield, and I've put it to the low side, which is ground right here. So now we can go ahead and mark off this capacitor as being replaced. Okay, before I put this tube back in its holder, I'd like to measure these two resistors. They're both 1 meg resistors. Yeah, that's reading about 1 meg. Oh, that's off. Let's remove that wire and check it again. Okay, that's pretty close. Okay, I'll put that wire back on and we'll get the tube remounted back in. Okay, what I'd like to do is I'd like to measure this capacitor, see what the grid leak voltage is on this side. .4 volts and 43 volts. On the plate of the 12SH7 and 0.4 volts on the grid of the 12A6. So let's replace that and see what happens. Now I want to measure that again. That's 0.27 and it was 0.4. That's 44 volts. I'm curious, that's at 315. And it's at 277. And that should be 200. Yeah. Maybe it's that one. It's 200. Yeah, 200. Okay, so bias voltages are starting to look better. Let's go ahead and replace some more caps. Okay, let's measure a couple more resistors. This one should be a 390. That seems awfully far out. Okay, we need to unsolder that one. And then we have a 2.2 meg right down here. Okay, let's undo that lead. and then remeasure those. Okay, the new resistor should be a 390, and it's 399, 398. The gentleman that built this didn't believe in wire cutters, and he used the entire length of these leads on these components, and it's making it just next to impossible to get some of these off of here. That was 2 complete wraps around that lug that he used, and they've all been that way. Okay, and that one was a 2.3 meg, and it should be a 2.2. That's good. Okay, I changed the ground lug here from back here on this tab. I moved it to this tab. All these points are ground, just to cut back on lead length there. Okay, we've replaced all the capacitors. We had one or two bad resistors here. We had the bad switch, on-off switch. And we've let it warm up. And I've noticed that when we turn the gain up, we have a crackling at the lower end. Now I have shorted out the input, and I have measured this pot, and the pot appears to be good. I've cleaned it several times, but there was a video done a couple of years ago from Carlson's lab, and he showed that pin 4 of the 12SH7, when this pot was on the lower end, the bias here changed dramatically. And so he made a small modification here of putting a cap in between the center tap and pin 4, and then biased pin 4 to ground with a 5.6 meg resistor. Now I've measured pin 4, and it doesn't appear to have any real change when this pot is moved from ground on up. But what I'm going to do is I'm going to make that modification and see if that helps. So I'm going to get started on that. Okay, I've got the mod in there. And what I've done is I've put a 0.01 microfarad cap from the center tap to pin 4 and a 5.6 meg resistor to ground. Now when I turn the volume pot up and down, if you can see that, there is no crackling. Okay, let's remove the short on the front end. Oh, that's got plenty of gain. With the capacitors and defective resistors replaced, the mod done, the only thing we're waiting for now is the on-off switch, replacement of the front jacks with B and C connectors, and work on the cabinet. So we'll do that in the next part. If you found this video useful or entertaining, give me a thumbs up, and don't forget to click on the bell icon to be notified of upcoming videos. Stay safe, stay healthy, and thanks for watching.